Hello and welcome back. In this video, I will show you some other apps programmed in Macs that use MIDI or audio to produce sound. Some have been developed with students in mind. The first patcher I will show you is a variant of our drum machine. It is actually a step sequencer. In this case, instead of radio groups, I am using sliders to select the pitch. I changed the range for the sliders so they output a number between 0 and 12, thinking on the 12 notes of a chromatic scale. Since I don't want drum sounds for this app, our note out can be on any channel but channel 10. Since I only have one sound at a time, there is no need for a channel argument at all. Now, numbers from 0 to 12 represent a chromatic scale in the lowest range of the keyboard. To get to the middle range, I added 60 to all of the numbers output by the sliders. Remember that 60 is the MIDI number for middle C in the keyboard. You can add numbers depending on which octave you want your sequencer to be. I actually added the option for playing in 6 different octaves. You can do that by using a radio group and a U menu. I used a select object instead to bang on one of 6 messages that change the argument for the addition object. The pitch C in different octaves is separated by 12 semitones, so 0, 12, 24, 36, and so on are all C in different octaves. I also added a random object which randomizes the octave on every beat, and which you can turn on and off by using a gate and a toggle. In this sequencer, we can also change the sound by using the object program out and a number box. If you want to have different instruments for different sequencers, you would have to add the channel argument to the note out and the program out objects. In that way, program out 1 would change the sound for the note out 1, program out 2 of note out 2, and so on. This patcher is included in your examples folder, and it is very fun to play with. The next example is an additive oscillator that adds 3 oscillators slightly detuned. You can control the pitch with a MIDI keyboard or with the K slider object, which looks like a virtual keyboard. You can also control the degree in which the oscillators are detuned. There is also an object that lets you to visualize the shape of the waves as you tune or detune the oscillators. Using audio is different from using MIDI data, because MIDI data is numeric data that is sent eventually, meaning that it is sent whenever you press a button or a key in a MIDI keyboard. This data does not produce sound in your sound card, but it is the MIDI driver in your computer, which is MIDI capable, what translates the MIDI data you are sending, producing audio data that is then performed by your sound card. Audio objects produce data at audio rate, which, depending on the settings, is usually 44.1 kHz per second. These objects send messages directly to the audio drivers of your sound card. Because they are different in nature from other objects, audio objects have in their names the tilde symbol. The connectors on such objects are also different, thicker and with yellow stripes. Audio objects can only receive and send audio signal to other audio objects, but they can also receive a variety of messages. depending on each object's specifications. You can always check using the help files or the reference files. The next example is an additive synthesizer. Here, all of the oscillators oscillate at a rate which is a multiple of the fundamental pitch. You can turn each oscillator on and off and control the volume of each one as well. I included some presets so you can see how each waveform is achieved. Some presets even emulate some vowel sounds. In Max, you can develop instruments using several types of synthesis, such as frequency modulation synthesis, subtractive synthesis, and granular synthesis, and so on. The next couple of apps I developed thinking on K-12 students. One is a simple MIDI sequencer that generates an antecedent of which the user needs to create a consequent using only 3 different pitches. The second one is an audio sequencer that plays a series of audio files. I pre-cut short snippets of a piece using Audacity, a digital audio workstation software, and the user can pick the order of the snippets in the final mix.
Phenomena. 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 Phenomena.
Max 7 also comes with several pre-designed oscillators, filters, and other audio objects that you can use. One way to explore these objects is to simply include them in your patcher and going to the help files. Even if there is no help file for a specific object, you can always search for it in the internet. There are plenty of references in the Cycling74 website, and there are forums dedicated to Max MSP. There are also some great resources on YouTube, where you can find tons of tutorials for Max and also for other algorithmic software such as Pure Data, Open Music, Super Collider, and C-Sound. Another feature of Max is that it allows you to compile your patches as standalone applications, which can be opened in another computer that does not have Macs installed. This is useful to share your programs with friends and students so they can try them at home. I sincerely hope that this series of tutorials was useful for you, and thank you very much for watching.